Here's a quick coding riddle for you. If I compile and run this, which of the following is going to happen? Will A be greater? Will B be greater? Or will I see something else entirely? I'll give you the answer in 3, 2, 1. So the answer is going to be C. But what happens? So for the purposes of this video, we're going to say this is Java, but I've also tested this with C, and the same idea seems to apply. Let's slap some Java boilerplate on and go ahead and compile it, and not surprisingly, it does not compile. But why? You might think, okay, because 6 minus signs in a row is preposterous. And you're right, but that's not what the compiler tells me. The compiler says, I'm missing my semicolons. But I do have those semicolons. So to understand what's going on here, and to make this code with 6 minus signs compile and run, which we will do by the end of the video, we gotta understand what the compiler sees here. So from the compiler's point of view, what it wants to do is break this line into simple, clear pieces that we call tokens. And it wants to know how those tokens relate to each other. Now to do this, it's not AI powered. It uses very simple but fast rules. So the compiler's looking at this line and it sees this word int and it says, okay, you want an integer variable. What are you going to call that integer? You're going to call it A. And this next point I'm going to make seems very simple and obvious and dumb, but it's going to come up again later. How does the compiler know that int and A are two separate things? It knows because I have separated int and A using a space. So the next thing we've got is this equals sign, and here it does know that equals is not part of a word, so you could remove these two spaces and the compiler's perfectly fine with that. So moving on, we've got this variable 10. And of course 10 is a dumb variable name, right? Because we could change it, we could put 9 million in there and it would still say it's 10, but actually it contains 9 million. The name and what it represents really don't match up at all. Why would you ever name a variable 10? It's kind of a dumb choice, but to the compiler, one variable name is as good as the next. It already knows you declared 10 up on that line above. To the compiler, this is just, okay, it's an int that we already know about. Moving on. So next it gets to this minus sign, and the compiler, simple as it is, it does look one step ahead. And it sees this other minus sign, and it says, okay, I know what that is. That is the decrement operator. And decrement is a unary operator, and it needs to go with a variable, not a value. So the compiler looks around and it says, okay, decrement goes with the variable 10. And key point here, this is the suffix decrement operator. So what the suffix decrement operator does is, it decrements it, yes, but when it's doing math in that same line, it actually uses the undecremented original value to do the mathematical expression. Keep that in mind. So in a similar fashion, the compiler gets to these next two symbols, and it says, okay, that's the decrement operator. What variable does that decrement go with? And it looks around and it can't quite figure out how to match this decrement operator with a variable. And moreover, the compiler's a little bit confused about how this entire line fits together. So the compiler says, well, I don't really know what you're doing here. Maybe you should have finished the line already and put a semicolon at the end. Hence the error. So that's why we're getting this cryptic error message. Okay, but I really want to know what happens if I run this code with 6 minus signs in it. Is there any world in which 6 minus signs in a row with no parentheses whatsoever makes sense? There is. Let's look at it this way. These left 2 minus signs, those are going to be the decrement operator, and those go with the variable 10. These 2 minus signs on the far right are the decrement operator as well. Here they're the prefix decrement operator, and they go with the variable 9. Now this 4th minus sign that's right next to that, to me that just means like the same thing as if we write minus 10. I'm saying the negation of 10, minus 10. So this is just negation. I'm saying the negation of decremented 9. Finally, this last minus sign, the 3rd one, what is that doing? Hey, how about that's just simple, normal subtraction? We're all comfortable with that. So what I've got here is I want to take the variable 10, decrement it, and from that, I want to subtract the negation of decremented 9. But how do I convey that to the compiler? If you think about it, the compiler ran into trouble with these middle 2 minus signs, which it thought were a decrement operator, but I don't want to use those as a decrement operator. How do I convey that these 2 minus signs in the middle are not part of this decrement operator? Well, I separate them using spaces. So we're back at that original question, but I'm going to go ahead and put those spaces in. And I'll tell you that at this point this code will compile. You're welcome to try and run this for yourself. I've got Java and C code in the description if you want to run it at home. So what happens here? Will A be greater, B be greater, or is it still C, something else? I'll give you the answer in 3, 2, 1. So the answer is still C, but it does compile, it does not crash. So what's going on here? We're going to start with 10 minus minus. Now this does decrement 10, but this is the suffix decrement operator. So we do decrement this variable, and I'm going to show the value of that in this little chart. But then, to do the math in this line, we're actually going to use the undecremented original value. So I plug in a 10 here. Then I've got this minus, and that's just going to do subtraction. And actually, before we do the subtraction, we will simplify this entire right side because those operators have higher precedence than just normal subtraction. So I do minus minus 9. Now this is prefix decrement, so I actually take one away and then I use the value that has been decremented in the mathematical expression on this line. And so this will be minus minus 8, which is just the same thing as plus 8, and so we get the value of 18 for A. On to the next line. So here I'm doing 10 plus plus. And as before, I will increment the variable 10 back up to its value of 10, but I will use the value before it got incremented to do the math on this line. So let's put in a 9 here. Then I've got addition. And as before, I will process the right side of this addition fully before I do the addition itself, because unary plus and unary plus plus, unary increment, have higher precedence than just addition. So I do plus plus 9. This is prefix increment. So I add 1 to the value of 8 and get the value of 9. That goes into the variable, and I use the value that has been incremented to do the math on this line because it's prefix increment. So then I've got 9 plus the positive of 9. And of course, plus the positive is the same as simple addition. We've got 9 plus 9, bringing us to 18. So you can see, A was not greater, B was not greater, they turned out to be equal. Hope you enjoyed that video. Thanks for watching. Have a great day.